We are today at the RESITEC site to discuss challenges surrounding the circularity of the ingot manufacturing industry, where around 30 to 40% of Silicon Kerf is lost during the manufacturing process and ends up as waste. Moreover, the requirements for silicon for high-end applications currently represent a challenge. The incoming filter cake material has a typical moisture content of 40 to 50%, which together with a small particle size poses significant safety concerns for the processing. Let's see this process.
The Silicon Kerf is received in big bags from the suppliers and is delivered by trucks at our site in Glamsland. The filter cake is in the shape of lumps where the particles are densely packed together. The appearance is rather dry, despite the fact that the material contains up to 50% moisture. From some suppliers with poor routines for the Silicon Kerf material, the incoming material can contain foreign objects, illustrating the waste image that resides for this material. Inspection of all incoming material is therefore an important part of the reception procedure.
RESITEC has developed several industrial-scale process steps for the Silicon Kerf, starting from the incoming filter cake material. Depending on the source purity and the targeted end use, one or several of the processing steps can be conducted. There is no phase transformation involved in any of the processing steps, which are therefore low energy demanding, resulting in low carbon footprint silicon materials.
For a full route, the first step would be a purification, which is a chemical treatment targeted for the reduction of aluminum, nickel, iron and carbon. This is followed by a filter pressing of the material to obtain a purified filter cake.
For the second processing step, both a continuous and a batch drying process have been developed. The moisture level is taken down from the initial 40 to 50% to below 1%, while keeping the oxidation level of the silicon at a minimum and ensuring the necessary safety level.
For certain application, a powder material is desired. An industrial-scale deagglomeration step has therefore been developed. This is the third step and results in a powder material with D50 less than 1 micrometer. In addition to back into PV, the Icarus project targets two main high-end applications for the reuse of the recycled Silicon Kerf. The processed Silicon Kerf powder material from RESITEC is tested directly in these two high-end applications. One as anode material in lithium-ion battery with CDTech and SGL carbon. Two into thermoelectric modules with University of Cyprus and Morelli. The results are promising and the work have been presented in conferences and resulted in two peer-reviewed publications. RESITEC has produced silicon materials for the other pilots of the project for further purification to solar grade and in the manufacturing of aluminum silicon alloys. In addition, it is tested by CEA as a filling material in the beam for the wafering process.
We have presented today activities of the pilot addressing the treatment of Silicon Kerf. Processes has been developed to produce a silicon powder product targeted for high-value applications like lithium-ion batteries and thermoelectric modules. Results obtained in the testing of the recycled silicon powder are promising. Silicon Kerf from different sources have been produced in our pilot plant, and our pilot has also provided materials to the other project partners. Finally, if you want more information about Icarus, you can check our website and our LinkedIn account.